Hello, gals and guys. Mr. Ambrose here with another video, and we're actually going to start uh, reviewing for the AP exam from this point forward. Oh, wait a minute, who's calling me now? Oh, hi, Mrs. O'Brien. How are you doing?
Hey, Mr. Ambrose, long time no talk.
Yeah, so you're enjoying your quarantine time?
Yeah, learning how to play that guitar. Still as bad as I was.
So,
So what you up to?
actually, I'm recording a video for my Calc BC class. And actually, since I got you on the line, I was wondering if you have any advice for your former students that you'd like to share with them.
Oh, wow, of course I do. Hey, friends. Wow, it's been so long. Can you believe it's almost a year since I bribed you to come to Extra Help with cookies? Is it Chips Ahoy or Oreos? Or we sat in front talking in first period while we listened to music before class starts? Geez, I can't tell you how much I miss seeing your smiling faces each day. And I know these are hard times, and I hope your families are healthy and that you're happy. Oh, wow. Look at you guys. You've made it through BC. You're in the final stretch. Oh my God. And you're preparing for the exam. Well, I know Mr. Ambrose has done a phenomenal job instructing you, and I know he's going to do a phenomenal job getting things together for you to practice and do what you need to do to get ready for this very strange AP exam this year. Two questions, 45 minutes. Oh my God. Uh, but anyway, I guess what I'm going to do is channel my inner Hamilton, because you guys know Hamilton is like my favorite Broadway play. So here's my words of wisdom for you. Although the world is turned upside down, remember, don't give up your shot. So, for one last time, I'm telling you guys that you can do anything you set your mind to. Be well and be happy.
Uh,
And,
that's awesome, Mrs. O'Brien. Thank you so much.
well, you're welcome, and good luck studying and practicing. Be well. Talk to you soon, Mr. Ambrose.
Take care, Mrs. O'Brien. So that was great to talk with Mrs. O'Brien and to hear some words of wisdom from her. As I mentioned, we're going to be preparing for the AP exam from this point forward. And so to do that, I'm going to perhaps step up things just a little bit. I will say that the amount of work that I will require to hand in will not be any more than what I've done so far. So I will be making videos Monday, Wednesday, and Friday that I'll expect you to watch. Homework assignments that I designate that you have to submit, I'll still expect you to submit. And the quizzes, they'll be ongoing, but these will not be anything more than what I've already done in our online instruction. But I will say that every day during the week, I will be posting videos. I will also be posting practice problems, and these things are really necessary to truly get you prepared for the AP exam. So I would highly encourage you to try to keep up with these things. And please don't wait until the last week or the couple of days before the AP exam to try to do all this at once, because I just don't think your chances of being successful will be that high if you do that. So try to keep up with these things as best you can, and I'll try to do my best also to get you prepared for the AP exam. And the last thing, you could always send me questions, and I'll try to get back to you as soon as possible. But one of the other things that the district technically is allowing us to do is to perhaps give some extra help one-on-one over Google Meet. So if you have questions that you feel like you can't get answered by me sending you messages back to, and if you want to, we could do this Google Meet. So just let me know if you want to do that. Um, Another just thing to be aware of, the College Board is providing, daily videos going over types of problems. And I think that they are definitely really well done, and I think could benefit you as well. So if you have the time, the videos over the last week and going into this next week on these topics are definitely, I think, worthwhile if you have the time to try to go through to view. I think they'll be helpful to getting you prepared for the AP exam. And technically, they have videos for all the courses, so I will put these links up on Google Classroom. All right, so if you noticed before I got interrupted by Mrs. O'Brien, what I'd like to go over with you guys today is integration and integration like problems. Now, while you have your calculator and your Inspire calculator at home that you could use, I'm pretty sure that on the AP exam, they're going to structure their problems such that you're probably not going to have any benefit to use your calculator to do integration. They're going to set up problems in a way that whether you have the Inspire calculator or not, they're going to perhaps test your ability to show that you know how to perform the integration methods that I showed you this year. So let's take a look at this first example. So here we have a funny looking picture of what almost looks like a graph. We're told from 0 to 5, the function f, whose graph we see here, is continuous and differentiable. And they say that a portion of the graph has been obscured by this Tony Record coffee stain. It is known that this depth integral is equal to 8, and this depth integral here is equal to -3, and f of x is linear on the intervals from 0 to 1 and from 4 to 5. All right, so that's the information that we're provided. And so the first part that we're asked to do here is we're asked to evaluate this particular definite integral. So as we learned this year, in order to try to perhaps evaluate this definite integral, we can't just, it's going to be really difficult or challenging to try to evaluate this just solely using this graph of f of x here. We know that a definite integral of just a function is equal to the area that's captured between that graph and the x-axis. Because of this x here, we're going to have to do some work here to try to perhaps start the process of trying to find some antiderivative. And so one of the methods of integration that you guys learned this year was u substitution. And in this problem here, that method is going to work out well because if you notice, we have this function f of x squared minus 1. And this x squared minus 1 is inside the function f. And if we let u equal to that x squared minus 1, this is perhaps the start of the process of doing substitution to try to answer this problem. And if you recall, after we identified our inner function, right, we then found its derivative. So the derivative of x squared minus 1 is 2x. And then what we normally did was we solved for du, and du here would equal 2x dx. And I see now that if we perhaps substitute u in for this here, then we still have this x dx on the outside, but I have that right here. And so if we just divide both sides by 2, I know now that we can make a substitution here to actually help try to evaluate this definite integral. So I'm going to substitute u in for x squared minus 1. For x dx, I'm going to substitute in 1/2 du. And if you recall constants that are inside our integrand, we can move immediately outside of our definite integral. And if you notice, I've held off on writing the limits of integration here because when we were presented with this original problem, we're integrating with respect to the variable x. So these limits of integration, I claim, are technically in terms of the variable x. And if we're going to link this definite integral to this definite integral here, we can't keep 1 and 2 as our limits of integration. We have to convert these limits of integration over in terms of u. And we can do that by using this equation. So, for example, when x equals to 1, if we plug 1 in for x in this equation, well, 1 squared is 1, minus 1 will equal to 0. So this lower limit of integration will be 0. And then this upper limit integration, we'll have to plug 2 in for x, and 2 squared we know is 4, minus 1 is equal to 3. So now these are our limits of integration. And I claim that at this point, we have this integral that we're trying to, this definite integral, sorry, it's from u, 0 to 3, of f of u that we want to evaluate. And to evaluate that particular definite integral, right, we don't know an antiderivative for f of u, but we were told that these particular definite integrals have these values. And I claim that we can use them to essentially get the definite integral of the function f from 0 to 3. And I claim that in particular, we can get that definite integral by taking this definite integral here and subtracting a definite integral from 3 to 4. Because we learned that that's a true property of definite integrals, right? So this definite integral here, I claim, should equal the definite integral from 0 to 4 minus the definite integral from 3 to 4, right? Because, right, properties of definite integrals, if we were to add this definite integral to this integral here, the integral has limits of integration from 0 to 3 to 3 to 4, that should equal this definite integral from 0 to 4. And then another property of definite integrals that you learned this year is that if we want to flip these limits of integration, we could do that, but we have to change the sign that's outside this, which currently is a negative. We have to change that to a positive. And so now that we have this here, right, the definite integral, the definite integral from 0 to 4, we were told that definite integral of the function f was equal to 8. And then the definite integral from 4 to 3 of the function f was this negative 3. And at this point, right, we've answered the problem, and on your exam, right, you can leave your answer like this here because there's only basic arithmetic left to finish off this particular question. All right, so now here's another part to this particular question. We want to find and evaluate this particular definite integral. So once again, to try to evaluate this definite integral, we would perhaps want to try to find an antiderivative to this expression. But if you notice, again, we have this function f prime, and while, okay, we have this graph of f, so this function f should be the antiderivative of f prime, we're perhaps going to have to do some work to try to find the antiderivative of this. And substitution is going to come into play here. So another method of integration that you guys learned this year was integration by parts. And so, and that's that voodoo integration by parts. So if you recall, the formula to the voodoo integration by parts was the integral of u dv equals uv minus the integral of v du. And so the first thing that you typically want to do to help find the antiderivative to this was you try to solve for what is this u equal to. And the acronym LIATE is what we used, but that's not going to be helpful here because we don't know what type of a function f prime is. But, right, again, because you're starting with this here, you try to identify what u is, and then we try to, the rest of our integral was dv, and what we always had to do was from there, we had to derive u, and we had to integrate dv. And I claim that because of that, and because of the fact that we have information about the function f, f prime can't be u. F prime is really going to have to be our dv, and that means u is going to be this 2x. And so now that we have that set up, if u is 2x, that means du will equal to 2. If dv is equal to this, then v is going to, the antiderivative of f prime is just going to be f of x. And actually, for du, I'm just going to add on that dx. So now that we have this all set up, we can evaluate this particular definite integral, right? Because it starts off as u times v, so that's 2x times f of x. And this being a definite integral, we'll want to evaluate that from 0 to 4. And then we'll subtract our integral with limits of integration still from 0 to 4 of v du, which is f of x times 2 dx. And because of this 2 constant, I'm going to immediately just pull it out in front of this particular definite integral. And so now we can evaluate these expressions. So this expression here, we plug in the 4 first. So we'd have 2 times 4 times f of 4 minus then 2 times 0 times f of 0, right? And then for this particular definite integral, the nice thing is the definite integral from 0 to 4, again, we were told exactly what that is equal to. That's just 8. So that actually we can just substitute that value in. And now for some of you who may have liked to have left your answer like this here, I'm going to say that you really have to still evaluate f of 4 and f of 0. I know that's not calculus, but I strongly suspect that they'll want you to evaluate this because technically this is something you can't evaluate on a calculator. So you do need to evaluate f of 4, and based upon our graph, it appears that f of 4 is 3, so I'll substitute that in here. And the nice thing, while we perhaps can evaluate f of 0, I'm going to make my life easier because I know that whatever that is multiplied by 0, this is just going to be 0. I'm just going to write that. And now this here, we can leave our answer as such. All right, so I didn't get through everything that I wanted to do here, and this is another reason why I'll be posting more videos. So this particular example here, and perhaps another example or two, I will post on my Tuesday video to continue with just looking at integration. I will post problems that'll be practice problems that, again, while I'm not going to ask you to submit them as homework, I would highly recommend that you try to do them and ask me questions going forward. And please, please, please do not wait until like the last week or the couple of days before the AP exam to do these and ask me questions on them. I will try to help you out until the very end. But if you wait to the very end to do these problems, again, your chances of doing well, I think, are going to be really, really low. So, keep doing what you're doing. Try to keep up with, with everything, and not just for my class, for all your classes, but try to keep up with things. Right? You only have 3 weeks left until the AP exam starts. So this is the home stretch. So just keep up doing, what you're doing. And as always, if you have any questions whatsoever, please don't hesitate to ask me, and I'll try to get back to you as soon as possible. And as always, please take care, stay safe, and I'll talk to you soon.